radians in different systems like that. Most probably we use degrees here. Now we can define the angle as the union of two rays. Now we have to discuss types of angles. Types of angles. What are the different angles? The first, acute angle. An angle which has the measurement less than 90 degrees is nothing but an acute angle. And right angle. An angle which has the measurement exactly equals to 90 degrees is nothing but right angle. Third one, obtuse angle. An angle which has the measurement more than 90 degrees is nothing but an obtuse angle. Now, straight angle. An angle which has the measurement exactly 180 degrees is nothing but straight angle. And complete angle. An angle which has the measurement exactly 360 degrees is nothing but complete angle. The diagrams are like this here. We can identify this as acute angle, we can identify this as right angle, and we can identify this as obtuse angle, we can identify this as straight angle, and we can identify this as complete angle. These are the different types of angles. If the sum of two angles is 90 degrees, then the two angles are said to be as complementary angles. If an angle A plus an angle B is equals to 90 degrees, then A and B are complementary angles. Now supplementary angles. Sum of two angles is equals to 180 degrees. If A plus B is equals to 180 degrees, then A and B angles are said to be supplementary angles. Okay, it is the concept of the total angles covered here. So, supplementary angles, complementary angles. Now I want to quote you. If one angle is 30 degrees, then find out its complementary angle. Its complementary angle. What it could be? It could be 90 minus 30. That means 60 degrees. Its supplementary angle. Its supplementary angle. What it could be? It could be 180 minus 30. That means 150 degrees. That's it. Is the concept behind angles. Now we observe that a triangle has three angles. But as I said earlier, an angle is nothing but the union of two rays. But here no rays. How can we form an angle? See here, the sides of the triangle can be extended, so we can extend this side as like this, and we can extend this side as like this. So here these are two rays. Here is an angle formed. So it's absolutely correct. A triangle contains three angles. Now we are going to discuss the types of triangles. Classification of triangles. What is the classification of triangles? Classification of triangles. We can classify triangles based on two factors. What are the two factors? Number one, length of sides. Number two, measure of angles. According to length of sides, The following triangles are there. Number 1, equilateral triangle. How can we define an equilateral triangle? This is an equilateral triangle if all three sides are equal. In a triangle, if all three sides are equal, then the triangle is nothing but an equilateral triangle. It is the indication for equality. Here I put single lines on each side. That means all single lines are equal, so all three sides are equal. This is an equilateral triangle. How can we define an equilateral triangle? If in a triangle on all three sides are equal, then the triangle is nothing but an equilateral triangle. The next one is isosceles triangle. What is an isosceles triangle? Isosceles triangle contain two sides equal. That means here these two sides are equal and this is different. So I'm indicating here by putting the same lines on the same equal sides and different lines on the different side. It is the indication. By the indication we can say it is isosceles and it is equilateral, like that. Okay. Now how can we define an isosceles triangle? In a triangle, if any two sides are equal, then the triangle is called isosceles triangle. Third one, scalene triangle. Scalene triangle is a triangle with different sides. Here all three sides are different. I'm indicating like this: 1, 2, 3 lines. It indicates that all three sides are different here. These are the triangles according to the lengths of sides. These are the triangles according to the lengths of sides. Now, according to measure of angles. Measure of angles. According to measure of angles, the following triangles are there. Number 1, acute angle triangle. Acute angle triangle. As I said earlier, what it means, acute angle means below 90 degrees. In a triangle, all three angles are below 90 degrees. Then the triangle is called acute angle triangle. Next, number 2, right angle triangle. As I said earlier, right angle means 90 degrees. In a triangle, if one angle is exactly 90 degrees, then the triangle is called right angle triangle. Next, third one, obtuse angle triangle. Obtuse angle triangle is nothing but a triangle if one angle is more than 90 degrees. Then the triangle is called obtuse angle triangle. And these are the different types of triangles: acute angle triangle and right angle triangle and obtuse angle triangle. Now I'm going to explain an important formula for right angle triangle. It was proposed by Pythagoras, the great mathematician Pythagoras. He proposed that in a triangle, the side opposite to the right angle vertex is nothing but hypotenuse, and the others are sides, adjacent side and opposite side, something like that. Now here hypotenuse square is equals to side square plus side square. It is the formula proposed by Pythagoras. It will be helpful in applications of mathematics like trigonometry, etc. The next concept is combination. Here I am introducing the new triangle, right angled isosceles triangle. It is the triangle both right angle and isosceles. In a triangle, one angle is right angle and the two other sides are equal, then the triangle is called right angle isosceles triangle. Here these two sides are equal and here angle is 90 degrees, so it is called right angle isosceles triangle. Now I want to question you one thing. Is there any possibility to two right angles in a triangle? Is there any possibility in two right angles in a triangle? No. It was because right angle means 90 degrees. 92 right angles means 90 plus 90, that means 180. Here the addition of two right angles itself is equal to 180 degrees. But the triangle contains three angles. The next angle, you can say like the next angle should be equals to 0. But no angle should be equals to 0. If any of the three angles is equals to 0, then there is no triangle. We can't form a triangle. So there is no chance to occur two right angles in a triangle. So it was absolutely wrong. Two right angles in a triangle. No chance to form triangles here in this case. Next, the another question is two obtuse angles in a triangle. Is there any possibility? No. Simply we can say no, because there is no chance to two right angles in a triangle. Then how can I put two obtuse angles in a triangle? No. Obtuse angles means, that means 91, 91, 91 plus 91, 182. The sum of two angles itself is equals to 182 degrees. It's absolutely wrong. These are the questions. Then if one angle is 30 degrees and another angle is 60 degrees, then which type of triangle that is? We can say by finding the other angle. The property of triangle is the sum of three angles is equals to 180 degrees. We didn't know the third angle here. We can say x. Then 30 plus 60 plus x is equals to 180 degrees. 30 plus 60, 90 plus x is equals to 180 degrees. That means x equals to 180 minus 90. That means 90 degrees. So here the value of x is 90 degrees. That means this triangle is a right angle triangle. The next question is the ratio of angles is equals to 1:2:3. Then find out the angles. This means x, 2x, 3x are the angles. The sum of three angles of a triangle is 180 degrees. So x plus 2x plus 3x is equals to 180 degrees. That means 6x is equals to 180 degrees. That means x equals to 30 degrees. Here it is nothing but 180 by 6. 6 1s are 6 3s are 30 degrees. Now x is 30 degrees, 2x is 60 degrees, 3x is 90 degrees. This is the right angle triangle. Most probably this type of questions will arise in the concept of triangle. Now we have to know what is the area of triangle. We can define the area of triangle as area of triangle is equals to half base into height. Area of triangle is equals to half BH. That means half base times height. In a triangle ABC, here BC is base, something AD is height. So it is base and it is height, half BH. Next concept is this is the triangle concept in polygons. That's it. Thank you.